seniors.
The same for the seniors? The seniors will have a few less things on there. Are you a senior?
Yes.
I get you a copy of the final exam review early so that you can chip away at it. It's a little bit longer. I think I took off all the stuff. But you can use a note card, full size, so it has to be handwritten. As you have time during advisory and stuff. There's a couple here and there so that it doesn't seem like too much at the end.
Why don't talk to Mr. Morton?
Mr. who?
Mr. Morton.
Sure.
Want me to take a pass or?
Doesn't bother. Out today. Vivian. Okay, maybe there's makeup testing or something going on today. I'm not sure why they're not doing the pledge. But, so last time I saw you guys, we tested that mini unit, linear, piecewise, quadratics, and again, hopefully that felt okay to you. Hopefully most of that seemed like review to you. But we have one more big unit and then probably a couple small quizzes before we finish up for the semester. And within our big unit, we're going to do section 2.5, which focuses on the fundamental theorem of algebra. Sorry, calculus. We use fundamental theorem of calculus a lot. And then we'll do 2.6 and 2.7, which is on graphing rational functions, holes, vertical asymptotes, horizontal asymptotes, x-intercepts, y-intercepts. again, something you should have done in Algebra 2, but we just kind of go back over it and make sure that you haven't forgotten it. But for both of those topics, before we really dive into that unit, both of those topics need you to be able to do long division and synthetic division. So those are the two things we're going to focus on today. So both handouts you picked up are 110. So if you didn't staple those, you may want to staple them later. But let's look at a few examples together to make sure that you remember this process. And then I'll go over a few of them with you, have you practice one or two of them for some quick guided practice. Then at the end we'll compare and contrast the methods and when you can use one method and when you can't use another method. And then I'll ask you to finish up the practice, and that will be class for today. Okay, so for the first page here, all of these questions ask you to do two methods, do long division and synthetic division for the same problem. And the reason why I do this is because after we do a couple of them, most students feel a little bit more comfortable with synthetic division, so that's fine. You can start off with synthetic division, but as we'll talk about today in class, you also have to be able to do long division. So if you are pretty sure you have the right answer from synthetic division, it can help you in your catching mistakes and just your overall learning process with long division. Okay, but long division is considered an algorithm. But first off, we really have to set this up correctly. So the divisor has to go out front, and then what we're dividing it into looks like that. Okay, and the reason long division is called an algorithm is because it's got a couple steps to it, and we just repeat those couple steps as many times as we can. So the first part up here, this thing up here is going to be called the quotient, and the quotient is going to be the first part of our answer. So the first part of it needs to be the thing that you multiply by this to get this. So I'm going to pick out m, because m times m gives you m squared. Now you really don't multiply it just by m, you multiply it by the whole thing. So it also gets multiplied by -8. Now the most common mistake, and if I'd say there's one thing you need to really focus on today, is this next step. You really take all of this minus all of this. But writing it this way, students forget it way too often. What seems to work out a little bit better, if you just right away change the signs, so that's like distributing the negative, and add instead. So these two are supposed to add to 0. That's why I picked m here. But this is not -15m, this is 1m, because we're really subtracting a -8m, which is like adding 8m. And then you've got -11 that has nothing to combine with, so it just carries down. So those are really the only long division steps. Just now we start them over. Next part of my answer needs to be the thing times m that gives me m. So that would be 1, because 1 times m is m. But also 1 times -8 is -8. Before you forget, and I'm going to just start highlighting this step, because again, this is 99% of the errors. You really want to subtract all of this. So just change the signs and add instead. It's like you're distributing the negative and then doing adding. Okay, so now our algorithm's over, because there's nothing times m that's going to give you -3 besides a fraction that has m in the denominator, but we're not interested in that. So we need to know how to piece this together to give our answer. So the first part of your answer is the quotient, m plus 1. And I'm assuming when you guys first learned long division, it was probably just with numbers. It was long before you knew any algebra. You probably had a teacher that had you do something like r -3 for remainder -3. You remember doing that? Okay, mathematically, that's nonsense. The reason why your teachers did that is because you were too young to, you weren't learning about and using fractions. So do not write it that way. Your answer should be the quotient plus, you always need to put the remainder over the divisor. Our divisor is the thing we were dividing by. And of course, plus and negative, if you'd rather this just say minus, that's fine too. Same thing. But the remainder, you can't do R remainder. You actually need to add the remainder over the divisor. Okay, finish copying this one down, and then I'm going to do one more long division for you in question 2, and then I'm going to ask you to try it in question 3, then we'll come back and do synthetic division. Okay, so setup, divisor needs to come out front. The first part of your quotient needs to be the thing times n that gives you n squared, so that would be n. Then we multiply n by both of these. And then the second that I'm done multiplying, I'm going to change the signs and add. Do it again. Next part of my answer is 5, because 5 times n is 5n. 5 times negative 6 is negative 30. And I don't know why this is the case, but again, a lot of times you guys will switch the signs and add once, but not the second time. The remainder here is not negative 59. Change the signs and add. The remainder is just 1. Okay, and then finally, we just need to pair these things up to give our answer. So the quotient plus the remainder over the divisor. All of that is the answer. Okay, finish copying that one down, and then try question 3. So that should give you some quick feedback on if you remember this, or if you at least remember it after that those 2 examples. Let's see how you did, and make sure there's not any big red flags that you need to be careful about. Okay, so it's got to be set up correctly. First part of your answer should be n, because n times n gives you n squared. Also, n times 5 gives you 5n. I'd say the first thing I would check for is to see if you put 15 in here. If you put 15 in, you did not change the signs and add. It should be 5 in. And then 18 had nothing to combine with, so you're just trying to combine like terms. 18 plus nothing is 18. The next part of your answer should be 5, because 5 times n gives you 5n. Also, 5 times 5 is 25. Once again, your remainder is not 43. 43 is if you change the sign the first time, but not the second time. Change the signs and then add. This should be -7. So your final answer should be an n plus 5, that's your quotient, plus your remainder over your divisor. And if you'd rather say minus instead of plus a negative, that's okay too. But even if you don't remember long division very well, again, it's only a couple steps, but as long as you're very careful about changing these signs, then a couple practice questions should be enough. Okay, we're going to put long division to the side for a bit, so anything jumping out at you about question 3 you want clarification on? Okay, then let's go back to question 1 and talk about the same exact question but synthetic division. So we're doing the same thing, so we should end up with the same answer. So here in about 15-20 minutes when I give you time to work these, obviously if you're not getting the same answer, you know one of them's wrong and you need to reconsider. But for synthetic division, it's got a different setup. So where the divisor equals 0 is the number you put in the top left box. Then you have to list off the coefficients. So I have 1m squared, then I have -7 m's, and then I have a constant of -11. They have to be in decreasing order like that. This many of those, this many of the next thing, this many of the next thing, and the last thing should be your constant. But if you put these in a different order, synthetic division thinks you're solving something different. Okay, now synthetic division, usually people prefer this. I certainly do. Its algorithm is just a little bit quicker than long division, so you need to make sure you're paying attention here or you're going to miss the whole thing. There's only 2 steps to synthetic division after you get it set up. You should always add down. So 1 plus nothing is 1. And then the second step is to multiply. So these two get multiplied and go here. And then you do it again. Add down. Multiply these two and put it here. Add down. And you just keep doing that as many times as you can. Add down, multiply. Add down, multiply. Add down, multiply. Just keep going. Now this is close to your answer, but this doesn't mean anything. This is just 3 numbers, 1, 1, and -3. But we can turn that into the answer, but we have to put a little bit of thought into this. We started off with an m squared, and then we're dividing out an m. So what we're doing is lowering the degree by 1. So if it was a squared, after I divide that out, this represents how many m's I have. So now it's to the first. The next thing would be the next biggest thing, which would be the constant. And then the last thing should be the remainder. And the remainder still needs to be put over the divisor. Now I know it's tempting to put it over 8, but 8's not the divisor. 8 is just part of the setup for synthetic division. I have one of these, and this is a remainder. So again, The reason why I don't just throw out different questions is I think there's some value here for y'all to see that you're getting the same thing, different process. Okay, let's do that again with number 2, and then I'll have you try it with number 3. So where the divisor equals 0 is the number that goes in the top left box. Then you need to list off the coefficients in order. I've got 1n squared, negative 1n, and then a constant of negative 29. All of that's for the setup. And then we add down, multiply, add down, multiply, add down, multiply, and we do that until we can't anymore. So add down, 1 plus nothing is 1. Multiply these two, you get 6. Add down again, multiply again, add down again. And then finally, making sense out of these last numbers, this represented 1n squared, I believe. Yeah. So when I divide it by an n, I lower the degree by 1. So now this represents the number of n's. The next number would be the constant, and the last number is the remainder. Remainder still needs to be put over the divisor. So same thing we got with long division, just a different process. So let me zoom in here and leave it still. So finish copying that down, and you try the synthetic division on number 3. I'll be patient here, make sure everyone has enough time. But you should know if your answer to number 3 is correct, because it should be the same as what we got for long division. So if you're doing fine with that, you can move on and try another question while you wait. Is that long enough? Okay. So again, you have an idea. If yours is the same as long division, you don't have to follow me here. You're welcome to just work another question or start another question while you wait. But for synthetic division, you should have put a -5 in the top left. It's where the divisor equals 0. your coefficients should have been 1, 10, and 18, because the one with the biggest exponent, I have one of them, 10 of the next biggest, 18 of the next biggest. So that should have been your setup. Add down, 1 plus nothing is 1, multiply and put it here. Add down, multiply and put it here. Add down until you can't anymore. And then finally translate what these three numbers mean. So it started off as a quadratic. I divided a variable out, so it lowers the degree by 1. So this now represents the number of n's. This would represent the next biggest thing, which would be the constant. And the last thing will always represent the remainder. Remainder still has to be put over the divisor. And the divisor is n plus 5, not negative 5. Same thing. Okay, anything about that process? I'm assuming you did a lot of this in Algebra 2, right? So, and long division, you probably did a little bit. You at least practiced it some? Okay, good. Okay, let me give you 2 tips, and then we're going to jump all the way to the last page so that we can kind of compare and contrast these a bit. And then the rest of the class will be for you to practice a couple more of these. All right, so my first tip would be on number 4 and with the synthetic division. If you do this for synthetic division, you put a 5 here, say you've got one of these and then a negative 28. You need to understand that this doesn't work, because synthetic division only works if you put things in the right place. It assumes that the last number is the constant, because that should be the smallest thing, and it is. And then it assumes the thing next to it is the next biggest. So what this is actually saying is 1a minus 28. That's not what I have. I have 1a squared. So the only way for this to work is for you to say you have 1a squared, 0 a's, and then a constant of negative 28. If you don't put this 0 placeholder in here, synthetic division thinks you're working a different question. So as nice as the process is, and as much as most people prefer synthetic division, if you don't have something, if you're missing a variable, you better put a placeholder in. Otherwise, it's not going to work. Okay, one more tip on the next page is on a question like 6 and 7. Just for your own sanity, instead of dividing by 3 plus k, divide by k plus 3, or k minus 1. Like, you want it to look consistent. So it's not that it's not possible doing it the other way, but just to make it look and feel like the other questions, just switch the order of those terms. Okay, and then on to the back page. Oh, I'm sorry, to the front page. I'm sorry. There is a process. I guess it doesn't really matter today, but my last period class said that they hadn't heard this before, and this is going to be very useful when we start to doing graphing stuff in about a week. There is something called synthetic substitution, which is not any more work than I'm currently doing, but it's just knowing one little thing about synthetic division. If you pair up what you divided by and the remainder, that tells you a point on that graph. So I have no idea what that graph looks like, what this looks like, without a lot of work. But since if I'm doing this synthetic division for something anyway, it guarantees me that 8, negative 3 is a point on the graph. Over here, that function would have to have a point at 6, 1. On number 3, when we divided by negative 5, we get a remainder of negative 7. If you pair those two up, that would be a point on the graph. And that process is called synthetic substitution. And again, since it's not any more work, it's really kind of a shame that they don't push that on you harder in Algebra 2, because that's good information. The main thing is, a lot of times you guys are used to the remainder being 0, right? That's the most common type. And if it's 0, that means that that's a factor, and this would be a 0. And if it was 0, to be a 0, it has a y-intercept of 0, which makes sense with the point part. So anyway, you don't have to know that to survive the day, but it will be helpful later on. Okay, so now on to the back page. If we can work those same questions with long division and synthetic division, and 99% of people prefer synthetic division, then why do we even do long division? The answer is long division is the only type of polynomial division that always works. So it's kind of like the quadratic formula for dividing. If you're only going to ever learn one way to solve a quadratic, it has to be quadratic formula. If you're only going to ever learn one way to do polynomial division, it has to be long division, because it's the only one that works. So on the rest of this page, unlike the other pages, number 13, 14, 15, and 16, it doesn't say you have to do both methods. You can do whichever method you want, but you have to make sure that synthetic division is going to work. And synthetic division only works if you divide by 1x to the first plus a number or minus a number. It has to be in this setup. X plus 3, x minus 7, anything like that. So if you're not given directions and you're dividing by something like x plus a number or x minus a number, then you can do synthetic division if you prefer. So to give an example of this, number 11, we could not use synthetic division to divide these two. And the reason why not is because of that 2 out front. That's not just an x plus a 3, it's a 2x plus 3. Now, technically, you can learn a couple more steps and then do synthetic division this way. But honestly, I don't even memorize those steps. I couldn't tell you what those steps are off the top of my head, because you're going to need synthetic division for other stuff anyway. So good rule of thumb is x plus a number, x minus a number, synthetic division. If it's not set up that way, then you can't do it. But if you want to do long division, you certainly can, because it always works. So looking at 13, 14, 15, and 16. There's only one of those that you can use synthetic division on if you want to. The other 3 have to be long division. Or you can do all 4 as long division. Okay, so kind of resetting here. If you guys go back to the first one we didn't do together, which is number 4, I believe. I helped you set up number 4, but didn't finish it. So I guess you can do this any order you want to, but I would suggest you either start with synthetic division or long division, whichever one you feel like you're stronger at, and then do the other one to make sure you're getting the same answer. And if you're not getting the same answer, start to look at what step is it looking like it's different, because that's probably going to give you a big hint on where your mistake is. And I will check in with you guys in about 10 or 15 minutes and help clear up any questions you may have found. And then this assignment should be short enough that you should be able to complete this in class without any homework. I will pick this up the start of class on Wednesday, or you can turn it into Google Classroom as you finish. And it's already opened in Google Classroom, so I certainly encourage you to just turn it in as you finish it today. Now that you guys have had a chance to try a few of them, is there anything stands out? Any question that seems harder than the rest? Anything you want me to go over with you?
15.
15. Sure. Let's see if I Okay. So first thing that we have to notice is because this x is squared here, you cannot use synthetic division. You're going to have to use long division. The next thing is I start to write this, I see that this is not in standard form, which bothers me, so I'm going to rearrange it. Put the x squareds first, or x cubes, then the x squareds, then the x's, then the constant, just to make it look a little more familiar. Okay, you okay with those two parts? Okay. Alright, then it looks like the first part of our answer, the quotient should be 2x, because 2x times x squared would give us 2x cubed. But also 2x times 1 is 2x. Now here's probably where some people are going to have some issues here. You can put this 2x wherever you want to. I guess before I forget though, I should probably change these signs since that's the most common mistake. But even though you can put it here, putting it under an x squared kind of doesn't make sense because these aren't like terms. You can't force these together. These two are like terms. So a lot of people are going to just prefer to put the 2x with the sign changed under those because then it's a little bit easier to keep up with. So when I add these together, this goes to 0. That makes sense. That's why I picked the 2x. Now I need to combine all of this stuff together. I've got negative 8x squareds that have nothing else to combine with. And then these two would combine to be 1x. And again, it's just a little bit easier to not make that mistake if you line them up like that. And then negative 9 plus 0 would be negative 9. So optional if you line it up with the x's, but just a little bit easier to keep up with. Okay, and then repeat. Looks like the next part should be negative 8 because negative 8 times x squared would be negative 8x squared. Also, negative 8 times 1 would be negative 8. So again, you can put that here if you want to. Just be careful not to try to force these together because they're not like terms. You might want to line it up with the constant because those are like terms. Before you forget, change the signs and add. And then for this question, it looks like the algorithm part is finished because there's nothing times x squared that's going to give me an x unless you make a fraction with an x in the denominator, which we're not interested in doing. So as all long division questions go, first part of our answer is the quotient, and then the other part is the remainder. Remainder doesn't have to be a number. Remainder can be in terms of x over the divisor. Anything more specific about that one? Was it just a lining them up part? Yeah. Okay, does somebody else have anything else ready to ask?
Can you go for the long division on number 4?
Long division on number 4. So this has to go on the outside. This needs to go on the inside. Now, kind of like synthetic division, you have to say that you have 0 A's. Over here, I don't know that I really need to do this or that I even prefer it, but there are some people that like to say plus 0a here just for the kind of spacing issues. Again, I don't know that that's any better, but that might make the question seem easier to you. So it looks like a, because a times a gives us a squared, a times negative 5 would be negative 5a. Now again, if you put this little placeholder in here, it kind of makes sense that it lines up. A's and A's. Change the sign and add. Okay, and then it looks like the next part of our answer should be 5. 5 times a is 5a. Multiply, change the signs and add. And it looks like we should end up with an answer of a plus 5 plus negative 3 over a minus 5. Is that enough for that? So, again, just to be clear here, mathematically, synthetic division, if you don't put the 0 here, there's no chance you get it right, unless it's just a total coincidence. For long division, if it helps you to put that 0a in there for the spacer, then please do it. But technically, mathematically, you really shouldn't have to put it there for long division. As long as you make sure you only combine like terms together, you don't try to force that negative 28 that's a constant together with the 5a, which is not a constant. I'm going to switch the screen back here, but again, you guys have about 30 minutes, which I think should be enough time for you to finish and turn it in. But if that's not enough time, make sure you finish it up for homework and have it ready to turn in at the start of class on Wednesday, if you don't turn it in earlier on Google Classroom. But any other questions you guys find, just bring it up here or call me over, please.